Hello, I thought I should just do a little bit more of a video just talking about the Powerglove and its, ancillary thingamajiggies. This is the Powerglove, as you can see, and this is the interface. Oh, time to get a thumbnail. Thumbnail. Get a thumbnail. Something like that. Anyway, yeah, so why I went for the fingers. Obviously the Powerglove has more controls than that. You can go like forwards and up and down and stuff, but I really ain't a fan of that kind of stuff. I don't like the idea of requiring, I don't know. I like the fingers because you're using your fingers already. You're quite practiced and it's kind of a control that feels, you could take anywhere and it's fine. I'm not really a fan of all of this jargon, which is why I didn't include it in this iteration. It's not my thing. I like the simple stuff, which is why I like analog, because it's very easy to stay simple and sound raw and stuff. Like you're playing a guitar, you tend to kind of stick to a solid tone. When you're on a computer, it's very easy to get complicated with all of this fluff and flaff and crap, and it's just not my thing. I like keeping it simple and raw, and that's the whole thing about this is, this is directly controlling the pitch. Anybody can pick it up and go, they know what they're doing. A lot of these kind of controls and stuff, usually they're so convoluted that you can't actually tell what's going on. What am I controlling? I can imagine, like, you give this to your grandma and she's like holding it. It's like, well, what's actually happening here? I don't understand. When if you bend it and the pitch goes higher, then it all makes sense. Simple. Woo woo. Oh, the pitch is going crazy. Anyway, yeah. I digress. But so the actual Powerglove, very simple. I didn't go into this bit like I mentioned, not my thing, but I may do one day. I may wake up and go, I'm gonna make the ultrasound do things. I didn't do the keypad. Maybe one day. There are a lot of projects out there that touch on the keypad and stuff. It's not my thing. I just like the fingers. So technically, I didn't really need this. I could have got some of the pressure, some of the bend sensors, and just popped them in an oven glove. I glued this straight onto it. It's just a 3D printed box that took about 2 seconds to draw up and then put a hole in for the 5-pin DIN. Why did I go for a MIDI cable / 5-pin DIN? Well, basically, it's because it was the only cable that's got, I had lying around that had 5 cores. It needed 5 cores because there was 1, 2, 3, 4 fingers. And then it sent 5 volts into this. So the 5 volts is going into each of these sensors in parallel. So there's a 5-volt wire that literally wires to one wire on the side of all of these sensors. And then the other wires on these sensors literally just wire up to their designated pins on here, which I completely did randomly. And I didn't know which fingers were designated to which interface bit until I shot the video. To be honest, I'm so far gone from my like. I used to be reasonably OCD about things like that, and it's just completely disappeared. I just couldn't give a monkeys. I just like the art of leaving it to chance and just seeing what happens and then rolling with it. That is the art of that OCD. It's a very time-consuming thing. So yeah, 5-pin DIN. Get in focus. So I've got the 5-pin DIN, and then I had hot glue. Actually, no, that's not hot glue. I found a good thing, by the way. It's pretty cool. I haven't got it with me. It's I'll put a link below. It's basically glue that you glue on. You pop the glue around it, and it's like, when you go to the dentist, which I haven't for a while, and I probably should go reasonably soon because I probably haven't been in over 15 years. Oh, I should definitely go. Like you put ultraviolet light on it, and the ultraviolet light dries it and makes it rock solid. It's pretty cool. I mean, there's an obvious downside to this ultraviolet activated glue is if you glue 2 black things together, for instance, how are you going to get the light to shine into the thing? So it's only right for certain applications, and this one's right because I just, there's a lot of people who are like, oh, you got to put the holes in it, but it's like, why? This is solid. Oh, but you've got to make sure the holes are lined up. But no, get a bit of glue, pop it on the back, sort it. Doesn't need to be fancy. So yeah, on the back of here is the circuit that I spoke about. That is on the website. It is right here, but it's on the website. Do check it out. And it's 4 times. I basically breadboarded it. I was actually building and designing an offset attenuator boost module the other day, so it just so happened that I had already had it on a bit of breadboard what I was planning to do before I even decided to do this project. I started doing the Powerglove project on I sat down and started doing the video like the Powerglove on Thursday last week, so it was a very rushed project, and I just stayed up all night Thursday soldering this basically and committing to a design without even testing it. I didn't actually test it practically except for looking at the lights flashing. I didn't test the voltages coming out to see if it was going to work or not until I turned on the camera and started playing. Oh yeah, very last minute, like I said. So there is sadly no strip board layout for this. That's because I'm completely made it up as I went. It's on proto board, so it's not strip board, it's proto board. So it's like the ones where there's just so on this stuff. Oh, get in focus. Get in focus. Why won't you focus pocus? Focus pocus. So it's this stuff. If you can see, they're not actually connected together, so you have to make the connections on the back. And on the back of this, because I rather stupidly was a little bit optimistic with how much I could fit onto this single bit of proto board, it's an absolute mess underneath. You won't be able to see fully the carnage, but I got halfway through making the circuit and realised I've probably tried to squeeze too much in for a very improvised circuit build. But regardless, I've got to the end and it did work first time when I plugged it in because I built it very carefully. Luckily, because that could have been a lot of headache to try and rectify some issues. All of the panel, this is something that I learned quite late on in building, is make sure all of the wires coming from the panel going to a circuit are connected via like Molex connectors and stuff. These things are godsends because if you have a mistake or if you break something, you can completely remove the circuit from the situation. It's pretty good. As you can see, some of the resistors are actually on the panel. The capacitors for the slew rate are actually on the potentiometers there. So if you look at the circuit, basically it is, you're not going to see it. You're going to have to look at the picture on the website, links below. So it's just one big quad op-amp, the TLO 74. It goes from the Powerglove input, which is basically the sensor with 5 volts going in one side with a 7805 that is actually, if you look carefully, oh no, it's fallen off. It was glued to the panel right there. So it's glued to the panel, and then the 5 volts is going to the central pin of the 5-pin DIN. And then the voltage is coming out of the Powerglove into the first op-amp via a 100k resistor, which is in an inverting op-amp circuit. So it's a 100k resistor going in, and there's a 100k which gives it a gain of 1. And then it's got an offset of plus 12 volts and minus 12 volts. I was going to actually, and this goes with via 100k, I was going to make this a 200k, so it would offset it by plus minus half of that. But I realised that if I was sending 5 volts in here, I just wanted more control. It's not perfect. Now it goes via another 100k into this op-amp, which inverts it again. It's another inverting, but instead of a 100k on this, it's a 1M, so it times the gain by 10, which is a lot, which makes this offset knob very twiddly, very sensitive. But it's a quick fix for the problem that I had. If you put the offset after the boost, then this input is already offsetted by about 5 volts. It's just going to be unworkable. It just wouldn't work. And then it goes into the portamento part, the slide, which smooths off the circuit. I don't know what I did with this, but whenever I turn it up slightly, the voltage drops quite a bit. So it's a very rubbish design of a slew, but it's just a quick and dirty fix to get this working. And then there's a tiny little LED that's sort of giving you a signal of what is happening before the attenuator. The other thing to note is on these LEDs, you'll notice they're the same LED can go red and green. You'll notice that in the video. But that's because if you send positive voltage into it, it turns red. And if you send negative voltage into it, it turns green because because basically there's two LEDs wired in back to front in one LED. And yeah, if you turn it around, it changes colour from red to green. It's a bi-colour LED. I've heard that in like Radio Shack, it's called a free-colour LED because they call the quirk of rapidly switching between yellow and green makes a yellow colour. So you can actually get three colours out of it. But it's more like a bi-colour LED. But you can call it a whatever. That is wired up differently to these two because it's just a voltage follower. This is just like a buffer, so it goes into the positive, to the non-inverting input of the op amp, and it's just voltage follower. Going into the attenuator, which is basically, it kind of chooses whether it wants the signal to go into the inverting or the non-inverting input of the op amp, and then via a little bit of weighting and twisty, you're able to make it so you can twist it all one way, it inverts, all the other way, it doesn't invert, and then attenuates in between that. So that's the attenuator, and it's very useful because when I was doing this circuit, I couldn't remember whether the sensor was sending out, when you bend it, I couldn't remember whether the voltage was going up or down. Obviously it's going down now I think about it. That's very silly of me. But I just couldn't think about it. So I plopped an attenuator on it because I just, I like, this is literally make it up as you go and hope it's going to be okay. And then it just goes to the output via another tricolour or bicolour LED. That's all it is, and that's ×4 here. Made it up as I went. I just put the op amp in, and then I just crossed off all the resistors and just followed wires, and it just got very messy. And all in all, building this took about 3 hours, but it was an unpleasant 3 hours because it was a very messy build, and I just didn't know whether it was going to work at the end. But sometimes you just got to get through it, and if it doesn't work, then you just got to live with the fact you've wasted your time, and you just should have probably done a bit more preparation to start with. But sometimes being a bit jammy pays off. Anyway, I'll just plug it in quick. I'm not really going to be talking and playing it much, but why don't we just pop it in? I'm going to plug it in. Hopefully it all still works. Because I just unplugged this and then... Oh no! Oh, the slew. Oh, that scared me. I thought this side turned off. Another thing to note is I didn't have a tape measure here, so it's one of the I do it quite a bit here and there, but I completely did this by eye. I just put dots like where I thought the knobs would be, and I didn't measure it at all, and it looks reasonably in line. I'm quite pleased with this one. Sometimes I do that and they're like a definite like wonky, but these are actually quite solid, like completely by eye. Reasonably pleased. I ran out of silver Sharpie, so it's gold. 2, 2, 2, 2. 4 2s. Anyway, let's plug it in and just quickly have a go. So now I'll plug it in. As you can see, all of the lights are on because it's reasonably offset, but when I plug this in, then the 5 volts goes to the sensors, and then it sends back a little bit below 5 volts. So you'll see when I plug it in, the lights turn off because these are actually at the right kind of 0 point. They're at the 0 point when I plug in the Powerglove. It's it's gone to 0. And now when I squeeze it, oh, it's really uncomfortable. It makes your knuckles like really, like bending my knuckles. They're quite bruised from playing it for about 3 or 4 hours the other day. Like, it's not the most friendly of gloves, and that you'll know that because you've heard from people that it is not the finest of interfaces. But as you could see, yeah, and if I turn the attenuators, you can see they're opposite to the actual thing. If I turn the attenuator, these I've got a thumb squished, so I'm gonna turn it up, and now it's plus or minus. I really can't. I don't know. Let's find out, shall we? So I've got a sound. I've just got a simple sound. I'm just gonna plug in the 1 volt I'm going to plug in the voltage input of the oscillator into this one, and that is the middle finger. I'm going to go with this finger actually. So this is the index finger. That's the index finger, right? So I've got the index finger plugged in. Okay, so I've got the attenuators wired the wrong way round. You see it's red. You can hear that is without the slew. It's not smooth. So if you add a tiny bit of the slew, it removes that kind of fluctuation and noise from the whole circuit. And I found that happened in the lightsaber theremin as well. It was just a bit noisy. So I'll turn the slew on tiny. And then turn it off. If you turn it up too much, obviously it doesn't just control the pitch of things like. It's pretty good for filter. I quite like that. And then obviously I'll plug in another one, this finger, which is the middle finger. One day, I'm never gonna do it. I'll never do it. I'll kind of set it up. I'll resolder the wires on the back of this so it goes like thumb, index, middle finger, that finger that nobody ever knows the name of. One day I'll do that, but that's a lie. I'm never ever gonna open this up again and make the fingers be the right fingers. I'm just not that kind of person. Anyway, I'm gonna turn on a delay a bit. I'm gonna adjust the time of the delay. And then it goes into garbage mode at the bottom of the finger twist, so it's kind of cool, isn't it? Obviously I've got 2 delays plugged in here, so that means I've got 2 garbage modes to play with. Where's the next finger? The thumb as well, I've got to add, the thumb is not the best. It's not the best, it's really rigid. It's really hard to actually move your thumb in this, so you'll see that the thumb is a lot less responsive. You've really got to give the thumb some twisting and it's not friendly. So I try to keep it to the 3 fingers. Maybe if I thought forwards, I would have taken the thumb out and put it into the little finger. Or thought even further forwards, I would have just got a sensor from an electronics store or eBay or something and just plopped in a fifth controller and made this 5. But we're not all as forward thinking as everybody. Pretty cool. I'm actually, like, the more I play with this, the more I think I'm going to be using it live on tour, because I think it's really cool and it's really immediate. I'm going to have to sort out how rigid it is and how hard it is to actually move. I might even like put some plasters on my knuckles. So that's literally just an oscillator going into the filter over here. It's going into that filter and then it's going into one delay and another delay, and then the 2 delay times on the fingers, and then just the filter cut off. Oh, I thought that was... Ah, that's why. I'm gonna invert the delays so. But anyway, you get the idea. It kind of gets addictive, as you can tell, even with just such a mundane sort of sound that's just like, oh, it's a klaxon in the background. You can still find yourself sitting here playing with it. And you can do this, like I said, you don't need a power glove. You can literally get an oven glove or even just some gaffer tape and some fingers. Get some bend sensors. They're basically just long, thin bend sensors. I'll find a link and I'll put a link of something. They'll likely be on the internet, eBay or something. And then you can sort of make this offset circuit. There might be a simpler way of doing it, but this is just an analog way. It's just simple. You just offset the voltage, you boost the voltage, you kind of smooth the voltage a bit with just a capacitor, just acting as a bit of a smoother outerer, and then you kind of add a attenuator, which you do not need to add either. So as long as it's boosted, because it's a very small change in voltage, and it's offset, which doesn't even need to be offset, because if you think about it, if you're going to be controlling the filter, the actual filter cutoff knob is an offset in itself. You are basically offsetting the voltage, so you don't need to add an offset. If you've got, for instance, on a Eurorack, find something that can amplify a sound by like 10 times, maybe even more or something. So gain of 10 or something. I reckon something comes to mind. I'm trying to think of a circuit of a machine that might do it. Safety valve might do it, funnily enough. Like Cascade, something comes to mind by Fonk, is it? Fonk Cascade? Something like that. I don't know. Anyway, that's just a little video. Just hope it was sort of helpful if anybody's planning on working on something similar. Peace.